Today's topic is diffraction of light. In last video we discussed about interference. Interference is the property which is basically shown by waves. Similarly, diffraction is also a property which is generally exhibited by waves. Okay. Now, diffraction means, the definition that I have written, it is defined as the phenomenon of bending of waves around the corners of an obstacle into the region of geometrical shadow. What does this statement mean? Suppose there is a source of light S, and here we have an obstruction like this, opaque obstruction. So certainly light will not pass through it. Okay, and there is a screen, this one. So on the screen, since light cannot pass through this region, here on the screen at this region we are expecting a geometrical shadow, means shadow region. That shadow will be due to this object. Okay, but now practically it is seen that when light is allowed to pass through this obstacle, in the geometrical shadow region also we are getting some light intensity. Now why it happens? That means what happened here is, this light wave, when it goes or it passes through this sharp obstacle, this is a sharp edge, suppose this is a sharp edge, so there will be bending of light. That means light is supposed to strike here, but instead of that it may bend like this. Okay, similarly instead of striking here it may bend like this. So if it does, if it bends in this way, they will overlap. Okay, two or more waves will overlap, and as a result here in the geometrical region we are not getting any shadow. Means shadow will be there, but we are not getting, the entire region is not a shadow. Here we are getting light intensity also. Okay, so this phenomenon of bending of light is bending when it is passing through this obstacle, that is called diffraction, phenomenon of bending of light. Okay, now here we will discuss single slit diffraction pattern. Single slit. In interference we took double slit, that was Young's double slit experiment, but while discussing diffraction we are considering one slit, single slit. So suppose in this figure, this is the slit, this one AB is the slit. Okay, this is the obstruction, this one. Light main source of light is somewhere here, S. So from this source, in terms of wavefront, we'll get this kind of wavefront. Okay, now as this wavefront strikes here, there is the opening of the slit AB, right? Can we say that each and every point on the wavefront is behaving like a secondary source? We know this one from Huygens principle. So if each and every point is behaving like a secondary source, we can say that though it is a single slit, it is nothing but still it is a combination of a number of points or a number of source of light, because secondary source of light means they are nothing but source of light only, right? So many source of lights are there. Okay, in case of interference, if you remember, we considered two waves. Here infinite numbers of waves will be there, a large number of waves. Okay, now what happened is, suppose the extreme two waves means from A to 0, I mean O, and from B to O, when the extreme two rays meet at O, certainly they are traveling equal distances. Okay, so they will be in the same phase. Similarly, okay, I'm just drawing this part here. Suppose this is the slit. Okay, this is the slit, this is A, this is B, there is the screen. From A to O, B to O, they don't have path difference, they are meeting at point O. Now another source will be there just below A. From there also one light ray will go to O, just one point will be there above B. from there also another light ray will go. So this wave, I mean this one, this wave and this wave, this one, they are also traveling equal distances, equal path, so they will also meet in the same phase. And if there is no phase difference or path difference, this point O will be a bright point. Okay, and at point O, not only two waves but a number of waves will reach, but still they are reaching at the same phase. So this is called the central bright point, this one, central bright. Okay, now the central bright point will be spreaded over the screen for how much distance? This is the central bright. Suppose central bright will be this one. Central bright will finish, or the central bright will no more be in existence after crossing this region. After crossing this region means where the first dark is formed. As soon as the first dark is formed anywhere on the screen, then only the central bright will, that is the end point of the central bright. Anyways, we will discuss about it. So I think this much is clear how central bright is formed here. Now suppose another point we considered, P point. This is not the central bright, of course. P point we consider. Now suppose what I said, that point P will be the first dark, provided the path difference between the two extreme waves. Extreme wave means this one and this one, reaching at P is lambda. How much is the path difference? I said it is lambda. This is the path difference between extreme two waves. But as we know that there will be a number of sources, so a number of waves are actually meeting at P. Okay, and I said that if the path difference between this wave and this wave is lambda, then point P will be the first bright. Now let us see how. That's what I have written here, right? Here the first dark, not bright, okay, dark, the first dark fringe occurs when the path difference is lambda. Path difference between what? Between the extreme two waves. Okay, so for that, let us imagine the thing in this way. This is the slit screen. Point P1 is somewhere here. Suppose this is P1. I am just drawing this part. Okay, now from this A point, this is the thing is theoretical, you have to understand it. Okay, suppose from A the light wave is meeting at P, from B another light wave is meeting at P. I said that the path difference between these two is lambda. Okay, then I also told you that here all the points are behaving like a secondary source. So a point which is exactly at the middle of A and B, a light wave is coming out and it is reaching to point P. Now if the path difference between this and this is lambda, what will be the path difference between this and this? Suppose it is point C, the light which is originating from C, what will be the path difference between this and this? Half of it, lambda by 2, because it is exactly at the middle. Okay, path difference between A and B, I said it is lambda. That's why at P1 we are getting first dark. Then path difference between this AP and CP will be lambda by 2. Okay, now if AP and CP having a path difference lambda by 2, that means if the crest of A reaches to P1, then the trough of C will reach to P1. That is the meaning if the path difference is lambda by 2. Okay, lambda by 2 if it is the path difference. Remember that the crest of one wave is reaching to P means the trough of other one is reaching to P. So crest is positive, trough is negative, the intensity will be 0. That intensity at P1 will be 0 because of two waves, right? Which one? AP and CP. Done. We have many waves actually, just we consider two. Next, suppose just below A, from this point another wave is originating, and that is reaching to point P. Then below C also, from one point, suppose from this point another wave is reaching to P, P1. Then can we say this wave, this wave means the wave which is originating from this point and the wave which is originating from this point, what will be the path difference between them? If the path difference between AP and CP is lambda by 2, one point below A, one point below C, the path difference will remain same only. How much? Lambda by 2. So if it is lambda by 2, I am giving another name here, suppose Q, and this is R. So QP1 and RP1 are also having a phase difference of lambda by 2, path difference of lambda by 2. That means if the crest of QP1 reaches to P1, then the trough of RP1 will reach to P1. So that means they are again cancelling each other. So in this way the thing will go on up to point B. Okay. So can we say, since crest of one wave, trough of one wave and crest of one wave are meeting at P1, then resultant intensity will be what? 0. If the resultant intensity is 0, point P1 will be a dark one. Okay, that is the first dark if the path difference is lambda. I think it is clear. Okay, then we will see where will be the second dark. If the first dark is obtained at lambda, I said that the second dark will be obtained at 2 lambda. 2 lambda means when the path difference between the extreme two waves is 2 lambda, then we are getting the second dark. Okay, we'll discuss about it, but before that let us see that for first dark what we have written here. Alright, now see here in the figure, AP is less than BP. BP is travelling more distance. How much less? If you drop on perpendicular AN, then this much path BN is the extra one. So this is called the path difference. And I said that for the first dark, the path difference, that means BN, is lambda. Now see, if this angle is theta, this angle, this one, the angle between these two dotted line, okay. If it is theta, then this angle is also theta. Which angle? Angle BAN. Okay. We know this one, that angle between two lines and perpendicular of the two lines. I mean, if angle between two lines is theta, then their perpendicular will also have one angle theta, same only. By that principle, this is also theta. So in this triangle, if this is theta, triangle ABN, this BN is the perpendicular, base is AN, and hypotenuse is AB, this AB. Now AB is nothing but the slit width. Slit width is given by A. So can we say here sin theta in this case is perpendicular by hypotenuse. Perpendicular is BN, hypotenuse is A, means we can write like this, no? Sin theta is equal to BN by A. So A comes this side, means A sin theta is equal to what? BN. So that's what I have written here. BN means A sin theta. And we also know that if this is the first dark, P1 is the first dark, then this BN will be equal to lambda, or A sin theta will be equal to lambda, this one. And here I have written theta 1. The reason is that since this is the first dark, that is why I have written theta 1. This angle only. For first dark, I have just given a name theta 1, and this is lambda. Okay. So A comes down. This is sin theta 1 equals to lambda by A. Next, see here, when we have drawn this diagram, it is a magnified version of the actual thing, because the actual thing happens only within few millimeter. Within few millimeter, this pattern gets over. Okay, so that means if it is a very magnified version, then that means this angle theta originally is a very small angle. Here though it is looking like 30 degree or 40 degree, but in reality This is a very small angle, and as a result, since it is a small angle, sin theta 1 can be replaced by only theta 1. So that's what we have done in the next page here. Okay. Sin theta 1 will be equal to, this is theta 1, make it theta 1. Sin theta 1 nearly equal to theta 1, therefore theta 1 is equals to lambda by a. Okay. Similarly, this is called, this theta, this is called angular position of the first minimum or dark. Minimum means dark. Angular position, that is in terms of theta. Now what is the linear position? This one, angular position means, see, this is the center point. From center to P1, how much this line is deviating, by how much angle, that is the angular position. And linear position is this one, y. In interference also you got, from central maximum to this point, this is y, suppose y1. Okay, so we'll find out y1 now. Theta 1 we got, this angle we got. So for that, this y1 is called linear position. This is the angular position, this y1 is the linear position. How to get that? See, since the angle theta 1 is a small angle, again this one you make, this is theta 1, theta 1. Here in this case, all the angles that I have written, though by mistake I have not given here 1, you do it by yourself. Okay, so tan theta 1 is equals to theta 1, because for small angle sin theta equals to theta, tan theta equals to theta, so we can take this approximation. And theta 1 means just now we got lambda by a. Okay, then tan theta 1, see from the figure, tan theta 1 is equal to, from this figure, see, if this is a triangle, this dotted line, and this one, if it is a triangle, tan theta 1 means perpendicular by base, right? So perpendicular is y1, this will be y1 for first one, for first order, I mean for first arc. So perpendicular by base, base is this one, and this is nothing but the distance between the slit and screen, which is capital D. Okay, so that's what we have written, y1 by d equals to lambda by a, or from this y1 is equals to lambda d by a. So this is called the position of the first arc, or linear position. Linear position. What is the difference between angular position and linear position? See, only a capital D is multiplied, right? So this one you remember, because in next cases also we are using this. With angular position you just multiply capital D to get the linear position. Okay, so this is done. This is for the first minimum. Then, as I already said, that the central maximum will vanish as the first minimum is formed, or the central bright is vanished as soon as the first dark is formed. Now let us see what is the width of the this one, central maximum. So for that, the width of the central maximum, okay, this is the first dark, and central maximum is, it starts from here. So in the same way, if the first dark is here in the upward side, in downward direction also somewhere here at P2, I have written P2 just to denote that here also another dark will form, that is the first dark in downward direction. Okay, somewhere here, first dark in downward direction. Now if it is so, then what is the width of the central maximum? This one, the whole part, width of central maximum, that means y1, this side also what will get? Y1. So y1 plus y1, that will give us the width of the central maximum. Okay, so see, in the calculation also, width of central maximum, y1 plus y1, now y1 is how much? Lambda d by a. So lambda d by a plus lambda d by a, that means it is 2 lambda d by a. That means central maximum, the width of central maximum will be this much, 2 lambda d by a. Okay, remember this one. Next, okay, another thing, since it is a linear width, it is the this one width of central maximum, but linear width, not in terms of angle. Okay, because we use this one and this one was nothing but the linear position. Then in angular width, what it will be? As I already told you that from angular to linear, how do we convert? By multiplying d. So from linear to angular width of the central maximum, just this capital D will disappear. This D will disappear. Okay, so 2 lambda by A. Fine. So what we got till now in diffraction? We got the position of first minimum, first dark. Then we got the central maximum. We got the width of central maximum. We got the angular position and linear position of first minimum. Okay. Now I told you that the second minimum will be formed if the path difference between this one first wave and the second wave, means the extreme two waves, should be 2 lambda. And why it is so, that one will discuss in next video. Okay.